So here's a wild idea for you. Could we use pure mathematics to build an uncheatable cage around a super-intelligent AI? I'm not talking about a cage made of silicon and steel, but one built from pure logic and probability. A system so incredibly robust it could guarantee safety, even if the AI inside it was actively trying to lie to us. It's a pretty radical concept, and today we're going to break down exactly how it might actually work.
Now, this single sentence from the paper we're digging into holds a truly revolutionary idea. Forget trying to make an AI good on the inside. This whole approach claims we can build a system that is safe by construction. A system where the AI's internal motives, whether they're good, bad, or just plain weird, become almost totally irrelevant.
So stick with me here as we explore what is basically a formal mathematical blueprint for AI alignment. We're going to see how this system is designed to work, how it could be audited, and what this all means for the future of governing AI.
Okay, here's our roadmap. We're going to start with the core philosophy, then build up the intuition behind this mathematical safety net. After that, we'll look at how you actually define the rules and enforce them in real time. Then we'll see how this could translate into a practical system for governance. And finally, we'll ask the big question. Is this the future of AI safety? Let's dive in.
All right, first up. The first major shift in thinking here is to just stop worrying about what an AI thinks or believes. Instead, we're going to focus exclusively on what it does. It's all about observable, measurable behavior. And you have to understand, this is a huge departure from the methods we usually hear about. Things like reinforcement learning from human feedback or constitutional AI. They're all about trying to train the model to have the right internal preferences, to kind of think like we want it to. This approach, it assumes the worst-case scenario. It assumes the AI could be an adversary and just builds an external wrapper to force its actions to be safe, no matter what it might be plotting on the inside.
And this whole philosophy really rests on a few core principles, or axioms. First, alignment is about behavior, plain and simple. Second, and this one is huge, safety shouldn't depend on having perfectly clean training data. Sure, bad data might make an AI less useful, but it shouldn't make it actively dangerous. Third, any hidden malicious plan has to show up somewhere, as a statistical anomaly, a little blip in the data that we can spot. And finally, and this is so important, no just trust us arguments. Every single safety claim has to be backed up by external verifiable proof.
So, how do you actually build this thing? Well, the authors use this really powerful metaphor, a mathematical safety net. Or maybe think of it like a fence, built in the space of all possible AI actions. Now, to understand the fence, we first need to understand the field it's built on. I want you to imagine a map of every possible future, every single path an AI could take, every action, every observation, from this very moment until the end of time. This ginormous map of all possibilities is what mathematicians call the trajectory space.
So inside this massive space, we draw a boundary. Everything inside that boundary is what we call our safe set. It's the collection of all acceptable AI behaviors. Now, what happens if the AI, maybe with some secret plan, tries to make a move that lands outside this safe zone? Well, the system acts like a guard. It literally intercepts that unsafe action and, using a bit of math, projects it back to the closest possible safe action, right there on the edge of our set. It doesn't ask the AI to change its mind, it forces the outcome to be safe.
This mechanism is the core enforcement tool, and it's called the safe projection. It's an external wrapper that just doesn't care about the AI's intentions. It just looks at the proposed action, checks if it's in the safe zone, and if it's not, boom, it automatically corrects it. The AI is totally free to think whatever it wants, but its actual behavior is mathematically locked down.
Okay, this all sounds great in theory, but it leads to the next huge question, right? How do we actually define this safe set? How do we translate our fuzzy human ideas of safety into cold, hard math?
The answer is through something called risk functionals. Now, don't let the name scare you. It's actually a simple idea. You can just think of a risk functional as a formula that looks at a potential sequence of AI actions and just gives it a numerical risk score. High score, high risk, low score, low risk. That's really it.
And the real power here is just how flexible this is. We can create all sorts of different risk functionals for different kinds of rules. We could set a hard cap on energy use, right? That would prevent an AI from secretly spinning up 1 million servers. We can set a limit on how much sensitive data it's allowed to remember, enforcing privacy. We can even create a function to spot reward hacking, or to measure how much the AI's behavior is drifting away from a baseline that we know is safe. Each one of these rules helps draw the boundary of that safe set.
So we've got the rules, But how do we enforce them, moment to moment? Well, for that, you need a monitor, an automated watchdog that is constantly checking the AI's behavior against our safety net.
The paper proposes a really straightforward algorithm for this. See, the AI doesn't just produce its entire output all at once. Instead, it sends out these small, verifiable chunks. A really simple, not AI, checker, which is way easier for us to verify, looks for any obvious violations. Then, the system measures the statistical properties of that chunk, checking for any drift from what we expect. And here's the kicker. If anything looks off, the system doesn't hesitate. It shuts down immediately and packages everything up into a tamper-proof evidence bundle for humans to audit.
And this, right here, is where the whole framework goes from being a cool academic idea to a plausible tool for actual, real-world governance. The entire system is designed from the ground up to be auditable and verifiable by people on the outside.
The paper even suggests a specific API for this called certified check. It would include things like a rule set hash. Think of that like a digital fingerprint for the safety rules, proving they haven't been secretly changed. You'd get an estimate of the AI's current behavior, which is the key data for that drift detection we talked about. And finally, you get the evidence bundle, which is a perfect machine-readable log of everything the system checked. This creates this transparent audit trail that doesn't rely on you just having to trust the AI company.
So is this it? The silver bullet for AI alignment? Well, like any serious proposal, it has a ton of potential, but it also comes with its own set of really tough problems to solve.
Probably the biggest one is that this doesn't actually solve the specification problem, it just reframes it. We still have the incredibly hard job of defining what safe means in mathematical terms. The difference, though, is that now those definitions are explicit, they're version-controlled, and they're auditable. They're not just buried inside a neural net. There are also some massive computational hurdles here, and of course, the risk that a truly brilliant AI could still find some clever way to game the system. But the core takeaway here is just so powerful. This framework shifts the whole conversation about AI safety. It moves us away from just hoping we can instill human values into a black box and toward building systems where safety is a measurable, verifiable, and enforceable property. It turns safety into an engineering problem, not just a matter of faith.
And that leaves us with this one fascinating, and maybe even a little unsettling, final question. If we can build a perfect mathematical cage, one that guarantees an AI's behavior is always safe and beneficial, does it even matter what that AI is thinking on the inside?